Okay, so Coroneos are 100 integrals number 45. So this question here, we need to integrate x squared plus x plus 1, everything to the power of minus 1. So how would you do this question here? I guess the first step to do is we change that into a fraction first. Maybe that can help us to actually give us more information on what to do with this question. Now, once you change into a fraction, the first thing you should notice that is the denominator is a quadratic. So if the denominator is a quadratic, I'm thinking about inverse tangent integration. So therefore, we need to completing the square. So instead of having x squared plus x plus 1, what I need to do is try to complete the square of these quadratics. So we need to plus a quarter, which is a half to the power of 2, and minus a quarter plus 1. And this is what you need to do. All right, so after completing the square, you should be able to get x squared, x plus half square, and this one is just plus 3 over 4. So that's what you need to get as the first step. Now, once the first step has done, all right, then clearly this is the inverse trigonometry integration, especially this is an inverse tangent. So what I also need to do is, instead of writing 3 over 4, we need to write in terms of a square. So we need to change that into square root of 3 over 2 and square dx. All right, once this is done, everything's prepared. Now we can actually integrate it. So firstly, we need to take the reciprocal of what's this term here and put it in the front. That becomes 2 over square root of 3. Tangent inverse, put a big bracket, and then we need to use this fx. All right, the derivative of this fx is just equal to 1, and then we have it for the numerator. Okay, so we can just write down x plus half over what's inside this bracket, which is the square root of 3 over 2. And plus c. Obviously, we need to sort of simplify this a bit, otherwise this looks a bit ugly. So that's 2 over square root of 3, tangent inverse. Now what I can do is multiply 2 both top and bottom. Okay, by doing that, I can just cancel the denominator. I can cancel the fraction in the denominator of the big fraction. So you end up with 2x plus 1 over square root of 3. And that's what's inside the square. That's what's inside the brackets of the tangent inverse, and that looks much easier and neat for the answer for the question here. All right, and that's how you do this question here. Very interesting question. It's to the power of -1. You change that into a fraction, and then you realize this is a quadratic. So you start to do the completing the square, and then you're using the tangent inverse trigonometry integration to integrate this. Okay, thanks for watching.